We are now recording. So welcome everyone to our training session for Virginia Beach School Cybersecurity Competition. Today's class is going to be focusing on what is really a absolute minimum requirement for anyone wanting to do cybersecurity or networking, and that is the concept of IP addressing. Now, you may have had some IP addressing in the past. You may know all about IP addressing. You could be IP addressing experts. I don't know. But I'm going to go from the standpoint of that you are not an expert at IP addressing, that you have some basic understanding. Hopefully you've read Chapter 4 in Networking Essentials. Hopefully you watched the 2 videos that I sent out last week or the week before for you to look at. But one of the key things we need to really talk about, and by the way, I'm going to turn on my camera just so you can see my ugly face for a minute, and I'll turn it off. That's me. That's not me. That's probably what I look like most mornings, Chewbacca, but my name is Kelly Calder. I'm at Stanley Community College, and Brian is also on here. Brian is in class, so he's got himself muted. But we're going to be 2 of the main people working with you in the cybersecurity competition. We are really trying to get you to the point of where you are able to do the cybersecurity competition, but also at the same time really get you introduced to cybersecurity concepts, networking concepts, the world of IT, and all the fun stuff that goes with it. So that's where we're at. Now I'm going to, like I said, I'm going to mute, turn off my video because there's no need to watch my ugly self looking at you, but that is me. We're going to talk about IP addressing and what IP addresses are. Now let's go ahead and, the easiest way to think about an IP address is an IP address is simply an address. It is the location of a device on a network. Now, when we look at IP addresses, especially when we start looking at, I use Notepad a lot, folks, but we start looking at IP addresses. They are 32-bit addresses put in dotted decimal notation. So 192.168.12.1 is an IP address. That IP address is, for our sake, put in dotted decimal. In other words, it's put in a decimal format instead of a binary format. Now, the chapter talks a little bit about binary, and so I'm actually going to go over and just talk about that in the chapter itself. So every device, by the way, on a network has an IP address. If it doesn't, if for some reason it cannot find a DHCP server, then what's going to happen is it's going to give itself an IP address in what's called an automatic private IP address range. If you've ever seen an IP address on a machine or on an Xbox One, or on an Xbox 360, that was 169.254.something.something. If you ever see this, 169.254.some number, and folks, I apologize for my typing ahead of time. And it'll be a /24, which means there's a thing called a subnet mask, which can be 255.255.255.0. I apologize for my typing and mistakes, but I was hit by a truck, okay? And so you can see I've got a scar here where they put me back together. My hands still don't work well. So I was hit by a truck last March, and it's one of the reasons I was not at the cybersecurity competition last year, is because I was in Atlanta trying to put Humpty Dumpty back together again. So I apologize ahead of time for any typing mistakes. But this address, 169.254.XX, is what is known in the networking world as an APIPA, a PIPA, or an automatic private IP address. And it's given out mainly on Microsoft devices. It is Microsoft devices, in fact, when they cannot find a DHCP server. So it's really set up so if you ever want to take 2 Xbox Ones or 2 Xbox 360s, connect them together and play a game without a DHCP server, they can actually connect to one another. We've done that before to do LAN parties and those types of things. So that is still, though, an IP address because it is a 32-bit. Now you're sitting there going, okay, now how in the world is he getting 32 bits out of 192.168.12.1? Well, you can represent these octets. Now, just so you know, an octopus has 8 arms. An octagon has 8 sides. An octet has 8 bits. And so when we look at this IP address right here in the curriculum, and if you can see the curriculum, raise your hand real quick so I know you can see it. Just go, yeah, I'm seeing your screen, I see it. Or unmute yourself and say, yes, we see it. One of the two. I just want to make sure you are seeing my shared monitor.
I see it.
You got it? Okay, good. So you see right here, you got it? All right, good, Neil. And Sarah, hopefully you're hearing me and can see it. Right here, this 192.168.1.5, if you translate or convert, you don't really translate, if you convert this dotted decimal into binary, and I'm going to check the chat real quick, folks, just to make sure I'm not, okay, so Brian's got it. Into binary, this number right here is the same. In fact, the number here is the way that the computer sees it. It sees it as a 32-bit binary number. Now, we typically, when we do our translations, we typically do put in 11000000 dot, and we actually put in the dot simply because it makes it easier for us to see the octets. But and then 168, let's see, which would be 128, 0, that, 1010, 01, I think that's it, 000, is that right? Yeah, 2, 3, 4, 5, yeah, I believe that's right. And then 12, 1, 2, 3, 4, 5, 6, 7, 8, I think that's great. 12 is 128, 64, 32, 16, 8, 4, 2, 1. And then 1 is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, how do I get this? How do I know that 1 is 7 zeros and a 1? Well, each one of these positions are a binary position. And we look at it, we can take right here and we can say, okay, in an octet, each individual bit represents a position. And that position is 2 to some power. Okay? So in the very first bit position, it's 2 to the 0 power, which is always a 1. And then 2 to the 1, which is 2. 4, 8, 16, 32, 64, 128. The good news about octets, the highest you'll ever have to count is 128 as far as numbers. And 255 is the most value, because you will see in an octet, you have a 1, 2, 3, 4, 5, 6, 7, 8. If it's all zeros, what is the value? It's 0, okay, because no position is turned on. If it's 1, 2, 3, 4, 5, 6, 7, 8, the 1's position is turned on, and now you've got 1. If it's 1, 2, 3, 4, 5, 6, 7, 8, now we got to do this a little bit harder with this because it's not as apparent to us what's turned on. But if we go back over here and look, we'll see the 1's position, okay, and we'll actually line it up right here. And look at this octet. Okay. In this, the 1's position is not turned on. So the 1 is not on, so that value is not added in. But the 2 position is turned on. And so I go, all right, well, I know I've got at least 2. And then nothing else is turned on, so the value of this in decimal is 2. And that is honestly how you go about figuring out a binary number to decimal. You just add up the values. So if it was 1, 2, 3, 4, 5, 6, 7, 8, what do you think the value would be? Somebody can put it in chat if you want to. Here's a good question for you. All right, Neil says 129, and I'm going to agree with that. And one of the reasons I'm going to agree with it partially is because, first off, you know it's going to be an odd number because the 1 position is turned on. But now we look at our values in the octet and we say, okay, the 1 position is turned on. So I'm going to go down here and I'm going to say this. I'm actually say, okay, so 1's turned on. So I know it's the 1 value's on. Is there anything in the 2 position? No, so nothing's there. Anything in the 4 position? No. Anything in the 8? No. I need a plus right there. Okay. Anything in the 16? No. Anything in the 32? Yep. Nothing in the 64. But guess what? The 128 position is turned on, so we had to put the 128 value in there. So now 128 plus 1 equals 129. And again, if this is too simple and you already know binary, please let me know and I'll move on and we can talk about some other stuff. But that is how you convert a binary number into decimal. You look at the values in each position and you add them up. And remember, our values are always going to be 128, 64, 32, 16, 8, 4, 2, and 1. All right? So those are our values at the bit positions. And it's going to be 2 to the 0 power, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, which is just 2 times itself that number of times. And that's actually 128, not 127. All right? So again, we see our possible values then are from 0 to, if we add up and have all the bits turned on, 1, 2, 3, 4, 5, 6, 7, 8, our value is 255. So an octet, an individual octet on an IPv4 address cannot be any higher than 255. So all these hacking movies you watch where somebody put in 289.14.275. It's all bogus. It's all junk. The only true hacking that took place is if you watched in the Matrix when Trinity used an actual known hack to break into the power plant. That was an actual working hack that had been used in the past, and she executed it correctly, which is kind of neat. But this is the basis of what you're going to do in any network security, because guess what? One of your jobs will be to find what IP addresses are in use and what's being used on them. So if you've done any of the labs with Nmap, what Nmap does, it's a program that scans a group of computers, group of IP addresses, and determines what ports are open on those addresses. So if you don't have an IP address, you obviously can't scan it, and you can't obviously have anything associated with those ports. So this is an IPv4 address, and it is always represented for us in dotted decimal. The computer, however, sees it in binary. Questions about that? Questions about conversion? Here they've got the same thing again. You got 128 plus 64 equals 192, and that's where this 1100, all zeros, 1010100, I did get that right, is 168, because it's 128 plus 32 plus 8. The one here, they have a 1 instead of a 12. I've got 12, which was the 8 and 4 turned on. Oops, I'm pointing at stuff that's on the screen you can't see. So I got 8 and a 4 turned on. And then you have the final octet, which for them was a 5, which meant the 4 and the 1 position was turned on. Notice again, anytime there's a 0 in the 1's position, the number is going to be even. Anytime there's a 1 in the 1's position, or that 1's position is turned on, you will have an odd number, which is down the road when you get into some higher level Cisco things, you'll learn how to do access control lists that will block only even numbers, or only odd numbers, or only even subnets and odd subnets, and that is actually controlled by that last bit position in an IPv4 address. Any questions on this before we move forward? Cool little binary game here. This is just a little game that they put in that you can play, okay? And you're going outside into the community, so I'm not going to do that right now, but there's a little game you can play and do some binary. Now, again, IP addresses are all 32-bit addresses. They also are made up of typically at least 2 portions. And by that, all IP addresses typically have a network portion. Well, they will have a network portion and a host portion. This is kind of like, imagine your house number versus your street. So in other words, I may live at 2710 Smith Street, all right? Smith Street's the major network portion, and 2710 would be the host portion, because that's the actual host on that street, which is my house. Now, here's something that's interesting. They don't really cover this in this curriculum. They don't really cover this well in a lot of curriculums now, because they're going to expect you to say, well, how do I find the network or the host portion? Well, it's all based upon the subnet mask. So if I give you this subnet mask right here, okay, how many 1s are turned on in this subnet mask? Can anybody tell me? If I converted this to binary, what would it be? Somebody can unmute themselves if you want to. And again, please tell me if this is way below your level, because I really don't know, and I want to make sure I'm at the level that you need. Anybody know? 24. I got Brian saying 24. I got Neil saying 24. Neil, you go by Sandy or Neil?
Doesn't matter. I'm used to both.
Well, whichever one's preferred to you. Trust me, I'm named Kelly, so I get Miss Kelly called all the time. So
Might as well be Sandy then. That's my nickname.
all right, Sandy, we got you then. John says 81s, 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 and 80s. That is correct. So in other words, there are 24 ones in the subnet mask, sometimes represented as /24. So if you ever see this 255.255.255.0 in a networking text, or you see this, it means the exact same thing. There are 24 bits in the subnet mask, or 24 ones. That means that the IP address this subnet mask is associated with, the first 3 octets are network bits, and the last octet is a set of host bits. Okay, how do I know that? Well, it's because that's what a subnet mask does. Okay, the definition of a subnet mask, okay, it is the number of hosts. Well, what does subnet mask do? It determines the host network, and I many times say and subnetwork, and we'll talk about that in a little bit, and host portions of an IP address. That is the textbook definition of a subnet mask. It determines the network, subnetwork, and host portions of an IP address. Now, it does that by setting it to a 1 in the subnet mask. So if I tell you that you've got this mask and this network, 10.0.10.0, or even this IP address, 10.0.10.10, with a mask of 255.255.255.0. And I ask you, okay, tell me what is the network address of this IP address? What you would do is you would look at it. Now there's really, I'll show you how we do it if it's easy to see, and I'll show you how computers do it. If it's easy to see, we literally say, okay, well, we know the first 10 are network, the second 10 are network, or excuse me, the first 8 are network, the second 8, and the third 8. So the first 24. So my network is 10.0.10.0. And what's my host portion? It should be .10, because that last octet is the host portion. And we can do that by looking at where the ones are turned on. The bad news is computers are dumb, very dumb. And so they have to have a mathematical way of determining which portion of an IP address is the host and which portion is the network. They do it this way. They take and convert everything to binary again. So 128.64.32.16.8.4.2.1. 1, 2, 3, 4, 5, 6. And I'm actually going to split these out a little bit so they're a little bit easier for us to see. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go 1, 28, 64, 30, 16, 8, 4, 2, 1. And 2, 16, 8, 4, 2, 1. Okay. Now, we put the subnet mask down. 1, 2, 3, 4, 5, 6, 7, 8. Did I miss something somewhere? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. This is not lining up right. It's all good. It's 8 and 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. And then we've got 1, 2, 3, 4, 5, 6, 7, 8. Now that is the subnet mask in binary. Now, in order to determine the IP address, host portion, and network portion, the PC or network device will convert it to binary and we'll do an ANDing process. Now, ANDing is a mathematical formula, and the easiest way for me to kind of tell you this is to say it's like multiplication, although it's not multiplication, okay? It is a ANDing process to where basically a 0 and a 0 will equal 0. A 1 and a 1 will equal a 1. And a 0 and a 1 will equal 0. Okay, so fill that multiplication. So let's go in here and see what we get fall through here. So with 0 and 1 is a 0. So 0, 0, 0, 0. 1 and 1 is 1. 0, 1, 0. All right, so far. And then this is all 1s and 0s, so we should have 8 zeros. And then this will be 0, 0, 0, 1, 0, 1, 0. And then 0, 0, 0, 0, 0, 0, 0, 0. 8 zeros. By the way, I wish I had $1 for every 0 I've typed or put on a board. I would be insanely rich. You will notice what fell through was 10, 0, 10, 0. In other words, when you take an IP address in binary, you AND it to its subnet mask, what falls through is the network portion of the address. Now, you're all looking at me going, whoop-de-doo, what does that mean? Well, here's what it means is this. If we go to our diagram right here, we look at these PCs, we see we've got different networks. And I'm going to assume, and I'm going to tell you, we're assuming a mask of /24, okay? So, if PC 18.11 wants to send information to 18.33, here's what it will do. It will take its IP address, okay, so 18.11, and will AND it to its subnet mask. When it does that, what should fall through is 192.168.18.0. It will then take the destination IP address and AND it to its subnet mask. And when it does, what falls through? 192.168.18.0. So this PC then knows that it can send this information directly over to this PC. So if we were going to ping, you've all used ping in some of the labs we've had, the networking essentials labs. All right. When you ping, it has to determine if it's on the same network. And it does it by taking these IP addresses and ANDing them together with the subnet mask that's been configured and determining what network am I on, the host that's sending, what network is the receiving host on, and if they're on the same, I can send it directly. If they're not on the same network, this is where it gets interesting. So if 18.11 sends something over to 533 with a /24 mask on 18.11, it's going to find out it's on the 18.11 network over here, or 18.0 network, and the destination is on 192.168.5.0. It doesn't match. So what's it going to do? Well, have you ever wondered what that default gateway setting was for on your PC? That's what it's for. At that point, since this PC needs to ping 533, which is on a different network, if it's been configured with a default gateway, it will then send it over to the router that's its default gateway, which would be the IP address on the closest router port right here, which is going to be 1899, and then it will get sent across, if this router has a route, over to 533, and if all the routes and everything work, it will come back. So the ping will go out and come back. So subnet masks are an integral part of what we do with IP addresses. Without them, the whole IP version 4 falls apart, to be quite honest with you. Questions? What I just went over as far as the way that the machines make a decision about local versus remote hosts is a pretty important concept in basic networking and IP addressing. Again, if this is totally basic and too basic, please let me know. If you're all asleep, let me know. If you're actually surfing the net instead of watching the. Hey, I've been in I've been in many online trainings, so I know how it works. I'll try to keep you awake. Now, I'm going to talk a little bit about something that really doesn't get discussed much anymore, but I feel like it's important because you need to understand what is called classful IP addressing. Back in the old days, we had what were called classful IP addresses. These followed certain rules. For instance, in a class A, the first octet is always between 0 and 127. All right. Now, The important thing there is you also notice that means that the first bit position will be a 0 on the first octet. It has to be. There's no way around it because of the way that the mathematical calculations work out. If there's a 1 in the first, it's got to be 128. Okay, so this has to be a 0. So you basically have from 0 to 0, 1, 2, 3, 4, 5, 6, 7. So that's 0 to 127. That's how they come up with Class A. Now, they also decided that Class A addresses would have a default subnet mask of 255.0.0.0, which means Class A addresses had one octet, really only 7 bits. 7 bits of the first octet dedicated to the network, and then 24 bits dedicated to hosts. So it's a small number of networks with a very large number of hosts on those networks. Now, Class B was from 128 to 191 in the first octet, which meant it had to begin with a 10. Okay, so you basically had 10, 2, 3, 4, 5, 6, 7, 8, 2, 10, 1, 2, 3, 4, 5, 6, 7, 8. I got what you mean there. There's no doubt about that. 1, 2, 3, 4, 5, 6, 7, 8. Still 1 to me. All right. So basically, 128, which is this number right here, to 191, which is that number right there. It was also determined that there would be the default subnet mask would be 255.255.0.0. So you had roughly 2 to the 14th network bits, because 2 of the bits had to be reserved to be 10, and then you had 2 to the 16th bits for host. So fairly large number of networks, fairly large number of hosts on those networks. Class C was anything with the first octet 192 to 223, which was 110000 to 110 1, 2, 3, 4, 5, 6. 1 too many. Okay. All right. So first 3 bits had to be 110, and the default subnet mask was 255.255.255.0, which meant you had 24 bits, roughly 21 bits really, because you got these 3 110 had to be set to 110. But first 3 octets for network and the last octet for host. Large number of networks, fewer number of hosts. Now, I'm not going to go into everything for D. D was used for multicast, and it was 239. It's 239 to 2. What in the world did I just do? 239 to 2. I'm drawing a blank. I have been hit by a truck, so I get a little bit of an excuse. Help me out here, somebody. 239 to, excuse me, 224 to 239. That's it. 224 to 239. And everything above that, 240 to 255 was Class E. That was experimental. Class D was multicast. So if you ever see a 224 address, this is from multicast, and it's still in use, definitely on IPv4 networks today. So Class E's are not really used. But these were classful, and so I can look over here and say, hey, guess what? When I look at this network, that's a Class C. Why do I know that's a Class C? Well, a couple reasons. One, it begins with 192, so it tells me it's a Class C, and that's really the main reason. If I had no other information here, if I didn't have anything or know anything about the math, I would probably assume it was a /24 because it's a Class C. This is called classful addressing. We've kind of gotten away from this. We now use classless addressing, which is more just give me a network and then assign a mask to it. So 10.10.00/16 doesn't matter that this is a Class A. This is just a network that the first 8 bits are network bits, and the last first 16 bits are network bits, and the last 16 bits are host bits. So we kind of got away from classful, but it's important to know them because it's a good concept for when we get into subnetting and subnetting of addresses. Questions? No questions at all. You know all, see all, hear all. So we can go here and look at different networks, okay? And we've got some activities here for you. So a 10 network, 10.0.0 net. I'll let you do those. Hopefully you've done those already. Here's the ANDing process. 1 and 1 is a 1. Everything else is a 0. And again, it's basically our the process of multiplication, which I know it's not. Those of you who are math teachers, I know that. But a simple way to kind of think it is to do that. And they've got all examples here for you that I do in my little notepad. And again, here we go. Are you on my network? We go out and we AND the sending host. We'll AND its information and get a network. And then we'll look at the destination, AND it. If they match, you're on the same network and you can send directly to one another. If they are not on the same network, then it has to go to the router, the default gateway. All right, so why don't we subnet items? Well, one of the reasons, and we'll talk a lot about it, here are the different classes, A, B, and C. All right. One of the reasons we do it is because imagine I give you the network, and this is very common. In fact, it may be something that's used in your school, and that is this, 10.0.0/8. And I hand that to you, and I say, okay, this is your network. So everything that you do, okay, so it's Class A, right? Yeah, it's the Class A10 network. By the way, this is a private IP address because it's in the RFC 1918, which is the private IP address range. But how useful is this? This is one network of 2 to the 24th host. So it's basically one network of around 16,400,000 hosts. Not very useful, to be quite honest. So we're going to need a way to break this down, to subnet it. We're going to do that through the process of subnetting. Okay, and they've got your little items here, 16,777,000. Okay, I've got your little demonstration here to go through, and here's our private addresses for RFC 1918. Well, what I want to do is this. Let's define subnetting first. So the book definition of subnetting. It is borrowing host bits to increase the number of network bits. Okay, so we're going to take this network and I'm going to very quickly subnet it. I'm going to borrow 1 bit. Now, when you do that, you're going over right into this octet. Okay, and that octet has a value in the first position of 128. When you go to the first position and borrow it. So I would take this network /8 and it would become 2 networks. It would become 10.0.0.0 to 10.127.255.255, and the second subnet would be 10.0.0.0 to 10.255.255.255. All right, I'm going to put some space in here so you can see these and not be quite so on top of each other. So this one network became 2 subnets. And by the way, now it is a /9 because we borrowed 1 bit. Still not very useful because it's now 2 subnets of 2 to the 15th host because we only borrowed 1. Now the beauty is we can then borrow another, and we can borrow another, and we can borrow, and we can actually pluck out pieces to do VLSM. Okay, so let's imagine here's something that's neat to do. Your company is given 10.0.0/8. and you've got one office in Chicago and one office in New York. This is the only set of addresses you're going to have available to you. You could take it right now, borrow 1 bit, and take this first block and that'll go to Chicago. The second block will go to New York. And then once you start assigning addresses there in those other cities, you could then borrow from these to make more networks. So this, we could actually borrow one more bit. And if we move over one more bit, we're at 64. So then we're at 10.128.0.0 to 10. I do my math, 191.255.255. And Brian, if I butcher it, or anybody, if I make a mistake, please stop me, because again, I have been hit by a truck. They tell me I only get that excuse for another 6 months, but I think if you can survive being hit by a truck, you should be grandfathered in and get a little extra time. Oops. So now we took this one network that one subnet we assigned to New York, and now we've created 2 more subnets by borrowing an additional bit. All right. This is what we call VLSM, or subnetting a subnet. What you're going to find most often, quite honestly, is you're going to find this 10.0.0.0/8 subnetted down to 10.0.0.0/24, 10.0.1.0/24, 10.0.2.0/24, which means you've got a network of 10.0.0.0 to 10.0.0.0.255. That's your full network. All right. But I about guarantee you, in your classroom right now, you're using a 10 number. I would be shocked if you're not. You're probably on your own segment, got your own addressing scheme, or you may be behind your own little SOHO router if you're using a 192.168 number inside your network at school. More than likely, your PCs are on a 10 number, because most places take 10, subnet it out to be used for their environment, and then go from there. Why do we subnet again? We subnet to make the given network fit our scheme. Okay. For instance, again, going back up here, if this is what you were given, and you had a Chicago. By the way, I don't know if y'all know this, but the Chicago Cubs are the world champion. Yeah, I'm a Chicago Cubs fan. Sorry. And then you have New York. All right. So I've got 2 cities, 2 networks I've got to work with. I've got to have IP addresses for. But this was all I was given right here. Without subnetting, I'm done, because this is one network of 16,777,000 hosts. Well, I broke it down into 2 networks. And then I took that and broke it down again for New York, so I could have my uptown and my downtown offices. Now, quick question for you. Does anybody know how many hosts are in this subnet right here, and how we would figure it out? Anybody know? I'm going to give you a formula. 2 raised to the h power minus 2 equals, I did it again, equals the number of usable hosts in the subnet. Or actually in any network. But I'm going to say subnet right now. And h, still a little h, equals number of host bits. So somebody tell me real quickly, what is, and I'm gonna cheat. I ain't gonna lie to you, I'm gonna cheat. What are the number of host bits left? We've got a /9. How many we got left? Anybody? Anybody? Nobody knows? Nobody? We did a /9. We've got 9 bits that are our network bits. How many host bits are there? Should be 23, right? 32 minus 9 equals 23. So the number of host bits is 23. So if I take H, okay, so I take 2 and raise it. I hit the wrong line. That's not going to work, I promise you. I take 2 and raise it to the 23rd power. Roughly 8,388,606 hosts in this subnet. How about down here in a /24? How many host bits are there? 2 raised to the, anybody? It'd be 8, wouldn't it? Because we've got 24 bits for the network. 32 minus 24 would be 8. And that equals 256 minus 2. And it gives 254 usable hosts. Now, I can show you why you minus 2. The first address in this range right here is 10.0.0.0. If you look at that, all the host bits, you look at this last octet, all the host bits are 1, 2, 3, 4, 5, 6, 7, 8. They're all zeros. In an IP address, all the host bits cannot be zeros. Likewise, the last usable IP address in this network, or this subnet, is 10.0.0.255. Because remember, our octet has a maximum value of 0 to 255. And that is 1, 2, 3, 4, 5, 6, 7, 8. All ones. So an IP address can never have all ones in the host portion, because you're going to learn if it's all ones, this is the subnet broadcast address, and this is the subnet address. So if it's all zeros, it's the subnetwork address, or the network address. If it's all ones, it's the broadcast address. That, by the way, is why you lose those 2 right there. Minus 2, because the first one's the network address and the last one's the broadcast. Pretty cool, eh? You should all be shaking your head yes now. Okay, good. Now, the bad news is, forget everything you just learned, because IPv4 addresses are going away. Yeah, they are. I mean, don't forget everything I just told you, because yes, they are going away. All of the IPv4 addresses have been given out. However, for the foreseeable future, until everything can support IPv6, which most things can now, the problem is you're going to see many of the consumer level devices, like consumer level routers, they don't support it, or they're simply not turned on at the ISP level. For a while, we're still going to be using IPv4, especially as long as we've got the ability to do NAT translations. Does anybody know why IPv4 addresses run out? Any idea? Right now, how many of you have a phone in your pocket? Probably all of you. Okay. How many of you have at least one computer at home, or at least one network device? Like, you may have your DirecTV box, you may have your Dish Network box, you may have your Time Warner box that gets an IP address, Comcast box, your phones, your laptop, your Xbox, PS3, your Wii U, all those devices, your iPad, they all get IP addresses now. And because of that, we ran out of IP addresses some time back. In fact, the last usable Class C block was given out several years ago. Okay, now all that comes down to, we got to give things IP addresses, which is pretty neat. We give them static or dynamic IP addresses. Now, I want to go over for a second here and find right here my NetLab. Hopefully, I haven't logged me out. One of the things I want you to do, and I want you to be aware, and of course it logged me out. Competitions.stanley.edu is where you as students have access to a multitude of labs. I'm going to show you some of these labs. I'm going to actually go in here and I've got my instructor account. All of you are in here, and mine should be in here too. Yep, my student account. But you will see in the Network Plus, you've got all of these different labs that you have available. For instance, here's a lab that walks you through using ping, DNS, ARP, many of the protocols that you need to be able to find different machines on a network. Now, you can go in here and you can actually just give yourself a lab reservation. You've got 15 pods available that you can use, all of them exactly the same. You can click on the pod and you can schedule yourself up to 4 hours on a pod. Okay, I'll go up here a little bit further and you can see that you now have access to the pods. Now, I don't see it right now because it's not time for the actual reservation to be available. It's in a minute. Plus, I'm not logged in as my student account. I'm going to have to log in as my student account to show you that. Some of you have logged into competitions.stanley.edu, and some of you have not, which is fine. But I want to make sure you're aware of it so you know that it is there for you to use. One thing that if you're at home and you're using it, or you're anywhere and you're using it, and you get this, and it asks you for a remote access test, you must do the test in order for it to work. If you're in Chrome, it will download the JNLP. If you're in Firefox, it'll download it automatically and start running it. And you can see here there's at 3:30, so I was a doofus and put it at 3:30 instead of right now. So I'm just going to go ahead and make another one. Okay. But in Network Plus, excuse me, I had to click the wrong thing. In Network Plus, which you all have, the labs are pretty basic, but they do cover the items we have here. Again, here's TCP/IP protocols, other protocols. Let's actually go in and do that one. See if I can get all the way up to the red line. It's now until. Okay. And so, and for whatever reason, I cannot click in the correct place to save my life. I blame it on the truck. Okay, so they're all doing 3:30. So we'll let it do that. But I'll show you a couple more labs. Now, this is a student view, so you're actually going to click here, and you will see the classes you're in. Right now, each of you are you're in the Network Plus class, the Security Plus, the Ethical Hacking, and the Forensics class. These different labs, here's Security Plus. You can see all these different labs here. Capturing network traffic. This is a lab that shows you how to use Wireshark and how to use TCP dump and dump cap. Okay, so all these different packet sniffing tools. Now, I hope your instructors are talking to you about these tools. I teach my students a very simple concept. Jail is bad. All right, let's all repeat that to ourselves. Jail is bad. You don't want to go to jail. Don't use these tools on your network at school. Don't use these tools on a network you don't have permission to use them on. Okay. Now, you can run them at home. Normally, it should be fine. Just don't go sniffing other people's traffic because that can get you in trouble. Be aware that's the beauty of net labs in this competitions.stanley.edu. These are totally enclosed environments. So you're going to learn when you go back and you actually go to schedule yourself and you schedule this ethical hacking, okay, there's actually a lab that teaches you how to create a backdoor with Netcat, which is probably something you're going to want to be able to do for the competition. All right. Once you get in a system, you want a Netcat so you can get back in. Well, there's a Kali Linux box. There's all kind of boxes in here for you to do. You can do it on this lab, and you can break anything you want. All right, because they will return to their open or to their reset to a plain or a working format or snapshot when you're done. In fact, if you do this lab and then when you're done you want to keep playing and do other things, go for it. That's no problem. But be aware, you go and take and use Metasploit to break into a computer at school and then put a Netcat backdoor on it and you get kicked out of school, don't come crying to me, don't come crying to your instructor. we just told you, don't do it, okay? Only do it if you have permission to do it on the environment that you're in. I can't stress that enough. The jail is bad. Any questions about jail being bad? Okay, I think that's pretty self-explanatory. So this competitions.stanley.edu is where you will go to do all of your hands-on labs. We've even got forensics labs in here that talk about different types of forensics in the Windows registry and web browser. Now, a lot of this is way beyond what you're going to do in even the competition. I wanted to put it in here so that you could have it if you wanted to play with it, if you wanted to use it. I would focus for you on the Network Plus, Security Plus, and the ethical hacking labs at this time. All right. And eventually to get to 3:30, and I'll be actually able to go into the lab. All right, so when we get in the lab, I'll show you putting IP addresses on stuff. So dynamic IP addressing is when we get it via DHCP. I'll teach you a very easy thing to remember. Good old Aunt Dora. Good old Aunt Dora's DHCP discover, DHCP offer, request, and acknowledgement. Okay. So DHCP discovers when the PC boots up, sends out a DHCP discover and says, hey, are there any DHCP servers out there? So this is client initiated. The server will say, yes, in fact, there's a DHCP server, and here's an IP address you can use. The client then says, that's a mighty fine looking IP address. Can I use it? And the server finally says, yes, you can. And you get an IP address on the network dynamically. If at any point this goes wrong and you cannot find a DHCP server and you're running a Windows device, you will get an IP address in the 169.254 if it's a Windows device. Sandy says he's got 11 IP addresses at home for 2 adults. That's pretty common. Yeah, that's not all that uncommon, to be quite honest. I start doing the math and I'm like, all right, Xbox, 2 DirecTV boxes, phones, PCs. And yeah, suddenly you're at 10, 11 in a heartbeat. So you can see, and that's really, you think about as we see more of continental Africa coming online to the internet, you've got millions of people who are just getting access to the internet. And so it's no wonder we've run out of IP addresses at this point. So we got a DHCP address. We get an IP address via DHCP. We can see it on a Windows device with the IP config/all. If you're on a Linux machine, you can do an if config. And by the way, if you are on a Linux box and you don't find a DHCP server, many times the TCP/IP stack will not even initialize, so you won't get an IP address at all. Somebody just come in. Okay. So where do they come from? Again, DHCP servers. At your home, you probably are getting a DHCP IP address from your ISP. And there's our 4 steps. Good old Aunt Dora. Discover, offer, request, acknowledgement. All of these are sent to and that's the all ones MAC address or the MAC address. Which, by the way, one thing I didn't talk about, IP addresses are what we call logical addresses. There's absolutely no reason that your room gets a 10.0.122 number other than the fact that the room has been labeled as 122. It could very easily be 10.0.12.0/24. So those are logical addresses. Physical addresses are items called MAC addresses, and those are addresses that are physically burned into the MAC address on the PC itself. All right, and this shows you how you can set up a Cisco wireless router to hand out IP addresses. We've got a couple packet tracers on this. By the way, with Packet Tracer, be aware you do need version 7, but when you open up Packet Tracer, the neat thing about Packet Tracer, the really cool thing about it, is it is a simulation engine that lets you do labs without having to get into NetLab. So you'll see there's different places to do different labs. And you can see here, it actually will take you through and talk about the different things you need to do. So it will go and say, let's see, add 3 generic PCs. So we'll go over here and find our PCs, end devices, 3 generic PCs, 1, 2, 3. All right. It says after the lights have turned green, so connect each PC to an Ethernet port on the wireless router using straight through. So we'll click on the cables. We'll find straight through. We'll go here and we'll go Ethernet, and we'll connect to an Ethernet port. We'll do the same thing here. And you'll see it's still amber, so it means the ports are not up on the router yet. It's going through spanning tree if you haven't know what spanning tree is. We can open up the PC, look at the config, actually the desktop, and look at the IP configuration, see that it's set to static, so change it to dynamic. And then we can actually go to close this, and you can actually go to not a terminal, excuse me, a command prompt. Go to IP config /all. And you can see we've got a 169 number right now because that didn't come up. So I'm actually going to do an IP config renew. So we get an IP address. Yep, we got a 192.168.0 number. There's our subnet mask, so we know that the first 3 octets are the network portion, and the last octet is the host. So this is host.100, and then our default gateway is 192.168.0.1. And then we could go through the rest of this lab. And you'll notice here, look, this completion 11%. If you ever get stuck, just do click results or check results. And you can actually go over here and look at the assessment items, and it will tell you what items you need. Okay. It says that you've got these items completed, you don't have these items completed. Now, some of these labs, especially the ones with DHCP, on occasion you have to do a release renew a couple times, or renew to get it to give you the correct points. So, no big thing there. All right. But this is Packet Tracer, and it is available to you. You can download it in your Netacad by clicking. I'll show you this while we're here, so I'm thinking about it. But when you first log into Netacad, at the bottom, you should see an item that says Resources. Let's get in here, and your instructor may have already given you access to this. It'll be under Student Resources too, but if you're not, you can go down to Educational Resources, click Explore Resources, go down, find Packet Tracer, and you should be able to find Cisco Packet Tracer 7.0, and then download the 32-bit or the 64-bit, depending on what you're trying to run it on. All right, and if you're running Linux, there's a Linux version you can also use. So that's where it's available. It's also typically available under Student Resources. However, it was not available in the first version of Networking Essentials that we had available to us. So when we go to Student Resources, for whatever reason, Packet Tracer was not in here. Okay. So there's a know-how, but it's not Packet Tracer itself. So you have to get it from the first page. Okay. Any questions so far? I shouldn't have lost my place like that, but I did. That's Packet Tracer for you, available for use. I suggest doing the Packet Tracers inside of the courses because they are extremely useful. Throw all the way down to here. That would be our Packet Tracer. And then we talk about default gateway. You would be amazed the number of times people don't understand the default gateway. Your default gateway is your way out of your network. If you need to get out of your network, it must go through your default gateway. Remember, the way we figure out whether or not we need to go outside of our network is by taking the source IP address, adding it to the mask to find out what network it's on. Take the destination IP address, and it to the sending machine's MAC address, or excuse me, subnet mask, and see what network falls through. If they match, you don't need a default gateway. You just go directly to it. If they don't match, that's when you need a default gateway to send it to. So that is really IP addressing basics Okay. When we get a little more involved, we'll go over here and actually pull them up. See if we can get this up and running now. All right, so these are up and running. So we actually go into the networking pod and show you the pod itself. You'll see the different Windows systems we have available. You also click Show Lab Content, which gives you the lab itself, which I usually have to look at right now because I don't know all the passwords to the different 400 different labs I have to go into daily. Okay, now one little thing I will warn you about, if you hit Control-Delete right here, you'll actually hit Control-Delete on your PC, so don't do that. Instead, go to PC, send Control-Delete. All right, and then we're going to find our passwords, which I think is p@ss2. I could be wrong, but I'm going to try it. Just tell them. Yep, p@ssw0rd, and it's in here. That actual information is in here on how to get into that machine. What we see here now, if you go and look under Control Panel, and I always change this to small icons, and networking sharing, change adapter settings, and then you can go in and play with this adapter and put IP addresses on it based upon the lab and what's needed. And it's already got 131.107.0.200. And notice its default gateway is 131.107.0.1. So these PCs are available for you to use, and all these labs are available. And they're great for you to be able to test out the different concepts that you find in the Networking Essentials course. Okay, go back to here, you go into the other lab, you'll see it's the same thing. The Network Plus concept, and you got the backtrack down here, which should be root and Tor to get you into it. Root, T-O-O-R, and I mistyped it. And then if you want a GUI, start X, and it will start the GUI for you. And you have the GUI available, and in some of the labs you don't need the GUI at all. This is Backtrack 5 R3, so it's not the newest thing for this Network Plus labs. If you go into the hacking labs, the ethical hacking labs, it uses Kali, so it's a newer item, but you still have there 15 pods for each one of them, so they're available for you to use. All right, I'm going to open it up for questions on IP addressing, but before I do that, I do want to talk just slightly about what we've gone over. Number one, IP addresses are a series of 32-bit addresses, or they are 32-bit addresses, normally shown in dotted decimal, which is this format right here. Okay. They are 32 bits because each of the sections are octets, so there are 8 bits in each octet. We have multiple classes of addresses that we can look at from a historical standpoint, class A, B, and C, and D. They actually showed you in the curriculum multicast address 223.239. All devices will have an IP address, and they will also be configured with a subnet mask. And remember, a subnet mask determines what portion of an IP address is the network and what portion is the host. Also remember that subnetting is the process of borrowing host bits to increase the number of network bits. Now, that's the amount of material that I would usually cover in about a week, as far as I would go in much more depth than I did right there. But I wanted to get you started and going because, again, I need to get a better idea. And if your instructors will kind of send me where you're at and what you're doing, especially what you're doing already in your networking courses, and get a little better idea of where I need to go with our classes. But I want you to be aware too that you've got a multitude of resources available to you. You've got all those NetLabs labs. You've got the Networking Essentials course. You've got Cybersecurity Essentials course. You've got really more labs than you can complete, to be quite honest with you, when you get into the number of labs that are available. I won't say it's more than you can complete because some of you may want to do nothing but labs, which is fine too. But you've got your option of playing with as many labs as you want and as many different devices as you want. As we get closer to, it's actually still booting, as we get closer to the competition, you will also have access to a pod that is built to resemble the competition so that you can actually practice. At this point in January, I hope you're excited about the Cybersecurity Essentials competition. I hope you're excited about networking. I hope you're excited about the access to these labs you have. To be honest with you, this is the equivalent of giving you 4 classes at the community college for free, because we don't normally have these classes all in one box like this for people. Instructors, are there any questions from you? No questions whatsoever. Everybody knows all, sees all, hears all. That always scares me. It means I've either done a great job or a horrible job. See, if config, this particular machine has an IP address of 192.168.9.2. I'm actually going to ping 192.168.9. Oops, if I can type it right. 9.1. And one thing about links pings, they're continuous. They don't stop until you stop them, so you hit Control-C. You'll notice it went out and pinged it no problem. And let's see if pfSense will let you ping to 0.52. Yep, you can ping all the way across. So it actually went to the pfSense, which was its default gateway. If we look at the if config, you can see the default gateway for this particular item is 192.168.9.1. It does that via broadcast of the 9.255. All right, are there any questions? Okay, I'm going to stop sharing my desktop. I am going to stop the recording.